Welcome, ladies and gentlemen. Today we start into what we call Chapter 3 and describing relationships between data. So in this section we've got some things to talk about, identifying what we call explanatory and response variables. In statistics we have different names. We don't use independent and dependent variables. We use these two names. We're going to construct scatterplots. We're going to interpret scatterplots, and then later on in the next couple videos, we're going to measure the linear association using something called correlation and interpret that correlation. So, explanatory and response variables. A lot of times we're going to use two variables in statistical studies. We don't just want to look at one thing that's happening, we want to look at multiple things that are happening in these studies. So we oftentimes will use two variables, calling them the response and explanatory variables. A response variable measures an outcome of a study. It's the outcome, it's the output. That's our dependent variable, guys. That's like our y. An explanatory variable may help explain or influence changes in the response variable. This is our independent variable that we're used to seeing. That's our x. So in many studies, the goal is to show that changes in the explanatory variable actually cause changes in a response variable. But there are a lot of pairings between explanatory and response variables that don't involve direct causation, simply correlated data. So as we move through different sections, as we look at different statistical methods, sometimes we're going to be looking at what can we say causes something else. What explanatory variables cause a certain response? Other times we won't be looking at this direct causation. So when we're looking at two variables, two quantitative variables, we use a scatter plot, and scatter plots are only for quantitative variables. So a scatter plot shows a relationship between two quantitative variables measured on the same individuals. Values of one variable appear on the horizontal axis, almost always the explanatory variable, and the value of the other one, usually the response variable, appear on the vertical. Each individual in the data appears as a point on the graph. So how do we make this? Well, first we decide which variable goes on each axis. Remember, explanatory, x-axis. Label and scale your axes. Say what the numbers on the axes mean and use an appropriate scale. And then we're going to plot the individual data values as ordered pairs. So here's some data. Body weight and pack weight. Body weight is our explanatory variable. What we're doing is we're wondering, is there a relationship between how much somebody weighs and how heavy their backpack is if they go backpacking? So we want to know if somebody gets bigger, should we expect them to be carrying more weight? So explanatory variable, response variable. So our x-axis will be body weight in pound and scaling starting at 100 and going by 10 pounds. Our response variable goes on the vertical scale starting at 20, going 22, 24, 26, going by 2's, labeled pack weight in pounds. Now what I would like to see, and this is something that's oftentimes left off of a statistical graph. What we have is a break in the graph like this. And usually we show that with a cut in the graph here, so we're making a jump from 0 to 26, and that's something that we really should show. In statistical books and statistical graphs, a lot of times that's left off. And then we plot all of our data values as ordered pairs. So, for instance, 120, 26 would be this point right here. Interpreting our scatter plots, we're going to follow what we did in Chapter 1 and 2, and we're going to be looking for patterns and important departures from those patterns. So when we look at our graph, we're looking for what's the pattern. Is it a line? Is it a curve? And is there anything that's real different from that pattern? And we're going to use three main terminologies to describe our pattern: direction, form, and strength. And we'll look at a couple examples of this. Those departures from the normal pattern we call outliers. We've seen those before. So here we have our scatter plot for pack weight and body weight. There's the basic overall trend. It looks like it's going up. There is a moderately strong positive linear relationship between body weight and pack weight. What that means is that it appears lighter students carry lighter backpacks, and consequently heavier students carry heavier backpacks overall. So we're talking about strength, direction, and form. It's a mostly linear relationship. This point here, this 185, 187 pound person appears to deviate quite a bit from the normal, the rest of these people. That would be considered an outlier. They're very different from the rest of the pattern. Positive association means when above values of one variable tend to accompany above average values in the other. So as one goes up, the other goes up. That's positive association. Negative association is when one variable goes up, the other one goes down. So it would be a downward trend this way. Positive association, negative association. Here's another scatter plot. This is SAT scores, the percent that took the SAT, and the mean math score. This one doesn't have as much of a linear relationship as it has a curved relationship. We say that there's a moderately strong negative curved relationship between the percent of students in a state who take the SAT and the mean SAT math score. Further, we see two distinct clusters of states and two possible outliers that fall outside the overall pattern. These two would be outliers. So again, strength, direction, form. Strong, it definitely has a curved shape. It's not really strong, but it's moderately strong. It's negatively trending, negative association, and it's curved. So we're looking at our socks, really. Take it back a couple sections. And we're using those same terminologies to do this, and we're incorporating strength, direction, and form every time we look at these scatter plots. And that, ladies and gentlemen, takes us to the end of today. Have a glorious and wonderful day.